It's the middle of summer and the sun is shining. You have been helping your parents outside with yard work for the past hour and you're sweating. After the work is done, you head inside to cool off in the air conditioning and grab a glass of water. Since you'll be going to the movies later, you decide to take a quick shower. You glance at yourself in the mirror before getting in, noticing that your face is slightly burnt. After your shower, you take another quick look to see if your sunburn is any worse. But wait, you forgot to turn the fan on, and the mirror is now covered with fog. You wipe a section with your hand and notice that there are small beads of water on the mirror. Where did the fog and beads of water come from? Condensation is the process by which water vapor in the air is changed into liquid water. In other words, the water in the air, a gas known as water vapor, from your hot shower cooled when it met the surface of the cold mirror. This caused the water vapor to condense or turn into its liquid form. You notice it as moisture or beads of water and fog that has formed on the mirror. You can also think of condensation in terms of being the opposite of evaporation, or the process of a liquid turning into a gas. This happens when a pot of water is boiled on the stove. The steam, another form of water vapor, and bubbles you see in the boiling pot of water are evidence of the liquid being changed into gas. The condensation point of water is the same as the boiling point of water. This occurs at 212 degrees Fahrenheit or 100 degrees Celsius. As you increase water up to and beyond 100 degrees Celsius, the water will boil. If you reverse the process and cool the water vapor down to and below 100 degrees Celsius, it will condense and return to liquid form. While condensation occurs at all temperatures between 32 Fahrenheit or 0 Celsius and 212 Fahrenheit or 100 Celsius, it is most noticeable when there is a large temperature difference between an object and the atmosphere. For example, you may see beads of water on the outside of a bucket of ice cream on a hot day. In this case, you can see condensation in action. However, 3 hours later, that bucket of ice cream is now melted, and the water on the outside may be gone. But condensation is still happening, just at a much smaller and slower rate, so it may not be noticeable. Keep in mind that there is always water in the air, even though we do not always see evidence of it. The condensation of water can be shown on a pressure temperature graph. A glass of water. The most common example of condensation is a cold glass of water on a hot day. The cold liquid is on the inside of the glass, but there are also beads of water on the outside of the glass. This is not the same water. The beads of water on the outside of a water glass are from water vapor in the air cooling off and condensing onto the glass. Planes. As planes cruise across the sky, their engines expel water vapor. From the ground, we can see the trails they leave behind. This is also a form of condensation. The water vapor from the engine is extremely hot, yet the outside air at 35,000 feet is about negative 40 degrees Fahrenheit. The rapid cooling of water vapor from the plane engine causes the water vapor to condense and cause cloud formation, or vapor trails. In fact, the formation of clouds themselves is caused by condensation of water vapor in the atmosphere condensing into a liquid state. Condensation occurs when the water vapor in the air is cooled, changing from a gas to a liquid. This process can take place at various temperatures between 32 and 212 degrees Fahrenheit or 0 and 100 degrees Celsius. It is most noticeable when there is a significant difference in the object and the temperature of the atmosphere. Some examples of condensation include sweat on a bucket of ice cream, beads of water on the outside of a cold glass of water, and the vapor trails we often see planes leave behind in the sky.